7.1 here is to find out the confidence interval when we are given sigma. If you remember what sigma about, right, is the standard deviation coming from the population, right? But if you see what's happening in the reality is, in terms of population, that means overall, like overall, what's the percentage of people will vote for this candidate? Usually we don't know that until the final results coming out. And the people, organization trying to predict that, is that right? So in other words, we don't know the overall population average. How do we know the overall population standard deviation? So in other words, in reality, sigma is not given. It shouldn't be given. So then in that case, we are in trouble. We cannot use that formula anymore, right? So if we are given sigma, we are using this formula, but if sigma is unknown, then we got stuck. We have to use something else, right? So that is coming to our 7.2, everybody. New section, when sigma is unknown. We want to use something that is similar to sigma. If you remember, something similar to sigma is the one that we mentioned several times, right? So everybody, for this table, I think you probably see that before, right? Let me see, how do I? Yes. That table here, you have a sample, you have the population, right? If we talk about the mean, right? From the sample, we have X bar. That's the sample average we are using, the notation. Overall population, we are using a mu, right? The variance, similarly, overall population, we are using sigma square. And then for the sample, we are using S square. Remember that beautiful formula we did before, right? So in other words, 7.2 here, what we will do is try to use S to mimic, to replace sigma, but not enough. We also need to do something else. We cannot just replace S by sigma. So in the formula, you will see, let me see. In the formula, you will see, you see, we replace previously, here is a sigma, now is S. Here is S. Let me erase those ones. Hold on. Where is the hold on. Where's the eraser? How do I get this eraser out? Yes. Okay, so I can erase this one here. Okay. Yep. So now we have this new formula here. If you pay attention to this new formula, what's happening here is we replace sigma by S, but not enough. What's happening? Somehow my mouse is moving around or something. Okay, so that's not enough. Why? Because you see that previously we have like Z alpha divided by 2. Now it's replaced by this T alpha divided by 2, right? That's something different, everybody, right? So this is X bar here. This is also X bar. I keep forgetting this bar here, right? So the first question, what's the T alpha divided by 2, everybody? So T alpha divided by 2 turns out to be a distribution to describe what's happening for this S, right? For this S. So the T distribution, what's the T distribution look like, everybody? There are several attributes here. It's very, very similar to the ones that we learned before, everybody. The T distribution is also a bell-shaped curve. So in other words, it's similar to the standard normal curve, the bell-shaped, right? Number 2, symmetric about the mean, the average, the center, the same. Mean, mode, median, they are all at 0. That's good, right? The same. All those are the same as the one we learned before. Level touch, x-axis, right? Number 1, 2, 3, 4, the same. Now, some different, everybody. Number 5, variance. Variance here is always greater than one, okay? As something that is special, right? Remember, what's the variance for the standard normal distribution? Everybody, do you remember that? What's the variance for the standard normal distribution? Anybody can type your answer here. If you remember that, what's the variance or what's the standard deviation for the standard normal distribution? Z. That should be equal to 1. Is that right? Equal to 1. Exactly right. Yeah. So, so that's the standard normal distribution equal to 1. But for this t distribution here, it is a bell-shaped curve, right? But is the variance has to be greater than 1. That's very special. Okay. Number 6, number 7 is even more special. Degree of freedom, right? That sometimes we got confused. What's that about, right? See. It tells you that a person, when I think he tried to publish these results because he was working for a company, some organization. So he cannot use his real name to publish. And then instead, he was using some fake name on the publication. What's that? They call student. Right, so you can see that. Where is that? I think it's somewhere. Let me see. Hold on. What's happening here? That's too big. Why this one is so big? Okay. Yes. Now, he was working for the it's something like a beer company. Is that right? Let me see. Is a beer company? Under the different students, okay. GUINNESS. I think it's some beer company, is that right? Like they are trying to see like ingredient, is that right? Like to make the good beer or something, right? So they not want their competitor know they are using the t-test to determine, let me see, okay, yes, so far so good, okay. So can determine the quality of the raw material. So that's the reason he was trying to use the fake name and using a student as sometimes they call student distribution or T distribution. But why it's called T? There's a name, right? It is well known that the work of Fisher. So Fisher is another famous statistician. And whenever you talk about stats, Fisher is one of the names you need to know. Anyway, you don't care about those, right? Who call the distribution student's distribution and represent the test value using a letter T. Okay, so that means the T starting from Fisher. Because Fisher says something, I think most people just follow that T, right? All right, anyway, that's a small story here. So now you see that the idea, right? The T distribution is that bell-shaped form, right? Bell-shaped form. So when you have a different sample size, you can understand different sample size, you have a different bell-shaped form, right? So you see the yellow one is like the smaller sample size here, right? The bigger the sample size, the more close to the black one here. Everybody, you follow me that? So the black one here is what? Is actually the black one is the same as the standard normal distribution. So in other words, the T distribution is really a mimic approximation for the standard normal distribution. So when you are getting more and more sample size, your distribution will be very, very close to that black standard normal distribution we learned before. Is that clear, everybody? Should I take a break here just to see anybody understand what I'm talking about here? The sample size. So this is similar to the one we mentioned before, right? Bell-shaped form. There are many, right? But the standard one, there's only one. right? Same as here. So that's for this piece here. Now, degree of freedom, I want to mention number 7 here. As n gets bigger, so that means the sample size gets bigger, it is more like the normal distribution. So that's the curve you see earlier. When you get a bigger sample size, right, the black one here is more close to the black. The sample size getting bigger. So that's what I mean. That's the concept here. Now, number 6 here is not that straightforward, everybody. Degree of freedom. It is not that straightforward. Even if you ask some people, PhD in mathematics or in statistics, right? Like ask them to explain what's the layman language explaining what do you mean by degree of freedom. That's not a straightforward one. So in the past, I'm trying to find out what's the best easy way, like for us to understand degree of freedom. Everybody, I think most of you have learned the equations, right? Let's use some equation to demo that. Okay, so you know what I'm talking about. So very simple equation, everybody. X plus y equal to, for example, 3, right? And I tell you x minus y is equal to 2, for example, okay? Right, everybody? This is we call this 2 equation together, a system of equations, right? So how many equations? We have 2 equations, right? 2 equations. How many variables? We have 2 variables. Is that right? Remember, like previously, I think in high school, probably in high school, right? If you remember, how do we solve that? We can solve that, right? 2 equation, 2 variable, we can solve that. Like you add them together. You add them together, you got 2x plus y minus y, got canceled, right? So 2x equal to 5. So x is equal to 2.5. So you solve the x. So y is equal to 0.5. For example, you solve for x and y. You can do that, right? And you know the answer right away. I mean, from the calculation, you know what's the answer for x, what's the answer for y, right? Now, what's happening is, what if I rewrite this? You only have 1 equation. And if I'm asking you, what's y should be? Everybody, right? So if I give you 1 equation, 2 variables, you see, that's very tricky, is that right? So if I try to solve this, like I will get y is equal to 3 minus x. So what does that mean? That means if you ask me what's the value of y, then you need to tell me what's the value of x first. Is that right? So that's somehow degree of freedom coming from here, because x is free to change, right? X could be anything, right? X equal to 1, y equal to 2, x equal to 2, y equal to 1, right? X is free to change. So that's the concept, degree of freedom coming from, everybody. So in that case, 2 variable, 1 equation, right? So what do we call this degree of freedom? Because x is free to change. So in that case, we say degree of freedom is equal to what? Is equal to 1, because x is free to change. Follow me? So far, so good? Right? Degree of freedom, because there's only 1 x. Now, what if I get a more complex x plus y plus z equal to 3? Then I'm asking you what's y should be, right? Right? Then I write an equation y is equal to 3 minus x and minus z. Then if you ask me what's the value of y, then I will ask you, tell me what's the x, what's z. Then I can tell you what's the value of y, right? So in that case, X is free to change. Z is also free to change. So those two of them is what do we call? Degree of freedom. They are free to change, everybody. They are degree of freedom 2 because X, both X and Z, they are free to change, right? I mean, we focus on Y. I mean, you can switch to the other one. It's also fine, right? Because if you focus on Z, then X and Y free to change. So degree of freedom is also 2. Follow me? Right? So now what if this case here, all right, let me see. I'm going to put that somewhere for up. Okay, yeah. So I'm trying to make good use of space here. What if I have like x1 plus x2, right? Da means I'm lazy, plus x n. Remember? Say now we have how many points? We have n data points. Sum size of n, remember? When you get n data points, sum size, right? Say this one is equal to some number, 100, for example, okay? Any number you can be, right? So in that case, and then we are trying to solve, say, one of them, right? In that case, the other n minus 1 value, they are free to change. So in that case, the degree of freedom is equal to what? Degree of freedom is equal to, everybody, what that should be? N minus 1. Let me see, anybody have questions? Oh, no. N minus 1. The degree of freedom here is n minus 1 because we always minus 1, right? Remember? Right. Here, when you have a 3 variable, all right. When you have 3 variable, right? 3 variable here, degree of freedom is 3 minus 1, which is 2, right? When you have a 2 variable, like x1, x2, or xy, right? Degree of freedom is 2 minus 1. Same as here. When you have n data points, degree of freedom, n minus 1, right? So that's the reason you see, everybody, you see why this is n minus 1 coming from. Follow me? Right? So this is the, I find out the most easy way to explain what's the degree of freedom. That's the one I find out so far, the most easy way, using the system of equation that you learned in high school, right? So it's not that new, right? Something that intuitively making sense. So that's the reason you see n minus 1, right? Now you understand why is n minus 1. Follow me? Okay. Now, okay, mouse. Now, so those are the 7 attributes we have started. And then next question is, how do we find out the value T alpha divided by 2, right? So previously, we have Z alpha divided by 2, right? So now the next focus for us is, how do we find out this T alpha divided by 2? Let's see. Let's do this from the examples, right? So here we are trying to study the average sleeping hours per person at night. Can we do a quick survey? Everybody, can you type on average in the last 1 week, how many sleeping hours per day you have? Can you type here? Yeah, thank you. Trying to wake up people, otherwise 6, okay, 8, 7, 6, okay, good. Okay, I see some line, 8, okay. 9, good. I mean, because at home, oh, I see 110, okay. Yeah, good enough sleep, right? Stay healthy. Okay, so we are trying to study this here, right? Like on average, how many hours of sleep per person, right? So to get that estimate, the range, right? We got some sample. Some sample, we randomly select 10 people, not that many, not 10 people. We want to find, out of those 10 people, we know their average sleeping hours, about 7.1 hour. I think our number here, I don't know, I got a feeling here is about 7 or 8, right? I mean, some 6, 5, 9, 8, yeah, 7 or 8, right? Yeah. So out of those 10 people, right, the average sleeping hours, 7.1 hours. This is the sample average. Everybody? They say their standard deviation, right? Remember, your English is better than mine, right? When they say their standard deviation, tell me, are they talking about the sample or are they talking about the overall population? So there should be the sample here, right? Those all 10 people, right? The 10 people, the sample, right? So that means that their standard deviation. So that means out of those 10 people, the standard deviation, right? You see, that's a tricky part here. Compare with the information we are given previously. If you compare with 7.1, the information is given is different. You see, they are trying to study something, right? They consider the average number of days to sell a car for dealer. And then given is standard deviation is about 6 days, right? So those standard deviation, they are together with like the sentence here is right after something they are trying to study. It's not right after they are saying about a sample. You see the difference, is that right? So that give you some hints, everybody. When you are using the Z formula, when you are using the T formula, right? You have to be, you have to figure out from the hints, right? When they say given is distribution, standard deviation, right? So that's like it's not related with any of sample here, right? We will print out this table, right? Because this table is like a Z table. We need to use that to find out what's the value, the probability, the value here. Okay, so how do we use this T table, everybody? T table is 1 page, everybody. That's easy, right? 1 page, you see, 1 page. So what's happening here is this T table is what do we call simplified T table. That's good enough, right? Good enough for our homework, our exams, right? In reality, when you work on the reality work, right? You may see some case you have to use the more complex T table, but this one here is good enough. It's pretty much, I would say, is 99% of the time is good enough. For us, it's 100% of the time is good enough because we can control which kind of a question showing up, right? Now, how do we find out those T alpha divided by 2, right? So let's go back. Remember, what's alpha? If you remember, we mentioned earlier, alpha is coming from the 1 minus the confidence. Is that right? Everybody? CI stands for confidence interval, right? When we say confidence is 95%, what's the alpha? Alpha is the probability of making mistakes. So in other words, if we have 95% of confidence, then we are allowed to have 5% of chance making mistakes, right? So that's the alpha. And so let's go back to the T table. Hold on, where's the T table? T table here, right? So everybody, when you look at a T table, what's happening is looking for the bottom here. Everybody, you see that one? It's very important tonight. You need to understand how do we use this T table. On the bottom, you see the confidence level here, is it right? So is that 90%, 95%, 98, 99, like all those percentage, right? Remember, most of the time, we are talking about 90%, 95%, 99%. Just 3 columns, right? So in other words, back to our question, we're talking about 95%. So we just need to look at the 95%, this column here, everybody. I really need your attention for the next 1 to 2 minutes. Everybody, don't fall asleep, okay? Wake up. 95% here. We are looking for some number for this column corresponding to this T alpha divided by 2, this number here. right? So how do we find out which number corresponding to this column, 95% here, determined, everybody, determined by which row, is right? Which row? So you see which row here, if you go to the top 95%, everybody, remember I say starting from the bottom, confidence interval, 95%, that's like 1, 2, 3, 4, 5, the 5 from the right, the fifth column. 1, 2, 3, 4, 5, fifth column, right? Everybody, you see that on the left is what? DF. Remember what that stands for? Degree of freedom. The one that we just mentioned, right? What's the degree of freedom? We mentioned that if you have a sample size n, what's the degree of freedom, everybody? Can you type your answer here? 9, that's right, Brandon. Yeah, that's right. Yeah, Sarah, that's right. Clara, yeah. Chris, Li Ping, Audra, that's right. Yeah, it is n-1, that's 9. So that means what? That means we are looking for the degree of freedom line. You see this row here. Thank you. Degree of freedom line here, right? I'm trying to get this row only, right? Somehow they give me the other rows. You see, I just try to highlight this row, right? But you know, line. We are looking for line. Let me get a pen here. Where's my pen? Where's my pen? Hold on. Where is my pen? Oh yes, yeah. So looking for this one here, right? Yes, this one. Yeah. So that is corresponding to the. Let me see. Corresponding to this row corresponding 1, 2, 3, 4, 5. Remember, we are saying that the fifth column from the right corresponding to 95%, right? So in other words, we are looking for this number, 2.262. That's what we say this T, everybody, T alpha. Oh, that's difficult. T alpha divided by 2, right? That's the number we got. Is that clear, everybody? Should I mention this one more time? That's very important, everybody. If you got lost here, I mean, you see, you don't know how to use this table, then you got stuck, right? Because we also have a lot of questions using this table, T table too. So one more time, where do we start from? We started from the bottom, right, everybody? The confidence level, right? Because that tells us 95%, right? Then we try to find out which row corresponding to, determined by degree of freedom here is n-1, which is n is 10 people. So n-1 is about 9, right? Yes. Okay. So we got this number here is 2.262. That's what we call this T alpha divided by 2. Everybody, I think I forget to mention previously, right? Last section, we have this Z alpha divided by 2, right? Write down this way. Right? We write down this way, okay? We don't write down this way, everybody. Z alpha divided by 2. We don't write down this way, everybody. Is that clear? You see why, I mean, why this way? Because divided by 2 is really divided by 2 from alpha. Right? So you want to put it like relatively small stuff here, is right? Alpha divided by 2. So you don't want to say Z alpha and everything divided by 2. That's not right. Okay. Same as this one. It's T, this alpha divided by 2, right? You don't write down this way, like T alpha and then overall divided by 2. That's not right. That's not right. Okay. So it's a smaller one. Okay. So hopefully it's more clear. So now we got this value T, right? Is 2.262. Now we can go back. So that's we can plug the value here. Everybody, you see that? 2.262. With that, everything, punch the numbers. We got 6.54 hours to 7.66 hours. If those 10 people, if it's a good representation of overall the people we are trying to study, right? So that means we have 95% of time, we can say, or you can say 95% of people, there we are sleep, average sleeping hours between 6.54 to 7.66 hours, right? Usually my sleeping hours is like somewhere 7 hours and 20 minutes, something like that, which is in this range, right? Anyway, so that's our first example. Any questions? So example number 2 here, everything is similar except one thing here. So this example here is a special because we are given a sequence of numbers for you here. So 1, 2, 3, 4, 5, 6, 7 numbers, right? So out of those 7 numbers, we can calculate what's the average. It's like a sample here, right? Sample, we want to find out 99% of the confidence based on this sample average. So from the sample average, we calculate by ourselves, we add them together, divided by 7, we got this much. Sample variance, we have this beautiful formula to calculate for us. Then we got the sample standard deviation, S, right? So in other words, this question here, are we given the population standard deviation or are we given the sample standard deviation? I mean, none of them, right? So the sample standard deviation, we have to calculate by ourselves. That's the trouble one, is that right? So everybody, if this question, happening on the homework, on an exam, you probably want to do this as the last one, right? Because that involves using this beautiful formula to do the calculation might take some time, right? So to find out the sample standard deviation. Now, once you find out the sample standard deviation, right, 1,610, you plug every number into the formula. Now, sample average, we got this, right? Sample average, we got this. Let me see, where's the pencil? Yes. I think I should keep that here. Trying to find out a good way to. Okay, so we know that, right? The sample average, as we know, sample size 7. What's this T alpha divided by 2? Everybody remember our first example? Like, where do we find out this number? We have to go to t-table, right? And remember, if I show you the t-table, where do we start from, right? The t-table. If I just show you the t-table, this table here, right? So where do we start from, right? So everybody, for the 1 tail, 2 tail, forget that stuff. We will come back this later. This is not for the moment, for later on stuff, right? Don't want to get confused. No worries for the first 2 rows here. We starting from the bottom, remember? Bottom tells us the confidence level, is that right? So what's the confidence level for this example here? We are talking about 99%, 99% here. Is that right, 99%? So that is the 99% here. So we are going to select one number out of this column. The question is which row, right? Which row to select from? Everybody remember which row we should select?
6.
6. How do you get that 6, Brandon? That's right. That's right. 7 minus 1. That's right. So the sample size is we have 7, right? Alex, Maria, Brandon, you're all right. Right. So it's n minus 1, right? So it is the what do you call this? N minus 1, the degree of freedom. So we got this, it is 6. Let's see, that's degree of freedom 6. So we are looking for this row. And then I think it's the third one from the right, that corresponding to 99, right? Yeah, the third one from the right, 99%, so 3.707. That's the number we should use. 3.707, you see that? So we got this range. So 99% of the time, they will fall in this range. So that's example number 2. Any questions?